assume this part of the class is mostly math, but then at the end we will see how to calculate the area under the graph, which will be how to calculate impulse if you have a graph force versus time. So the slope, what the slope is telling us how steep and in what direction the line is. The slope can be positive when it is going up, positive. The slope can be negative when it is going down, the line is going down, and the slope can be 0 when it is constant. The slope is always with letter M. It's known to be letter M, and it is always calculated as delta y over delta x, or the change of the vertical over the change of the horizontal. Whatever is the horizontal and whatever is the vertical, this will be representing the slope of the line. So let's suppose that we have a situation that looks like this. We have a force versus time graph, and for simplicity, again, we will say is newtons and seconds. And then we have a line that starts at +5 at 0, and then it goes up at 2.0 seconds is +12 newtons. So as soon as you see this, you should state, or you should have back in your mind, that the slope will be positive. But even the calculations will tell you that the slope is positive. So the slope, which is always delta vertical over, or change of vertical over change of horizontal, will be, the vertical change is this one here. And the horizontal change is this one here. Physically, the vertical change will represent the change of the force, because what we have on the vertical direction is the force, okay? And what do we have in the horizontal direction is the time. Make sense, guys? So in terms of the units, this slope will represent newtons over seconds in terms of the units. The slope, the physical meaning of this slope, okay, will be newtons over seconds, because force is in newtons, times is in seconds, so will be newtons over seconds. In terms of the value, will be whatever is the vertical change or the change of force, which will be force final minus force initial over T final minus T initial. So again, slope here. And force final is +12 minus, that is from the formula, +5 over T final, that is 2 minus 0, that is T initial. So the slope of this line, even mathematically, will be positive, because Positive 12 minus 5 is positive 7 over 2, or positive 3.50. And the units of this slope are newtons per seconds. When the line is a line that is falling down, so let's suppose that we have again force in newtons versus time in seconds, and then you have a line, a graph that follows something like this. When it starts at positive 10 newtons and it ends at positive 3 for 5.0 seconds, then the slope, again, it doesn't change. The slope will be again delta y over delta x. And when we say y in math, but it is whatever is on the vertical. So the change of force over the change of time. And the change, like any change, is final minus initial over change of time, again, is final minus initial. So the slope on this case will be final is positive 3 for force minus initial is positive 10 over final for time is 5. And notice here that I do not state the sign for time because time is a scalar quantity, minus 0. So the slope for this situation is what we were expecting it to be, because positive 3 minus positive 10 will be negative 7.0 over 5. And 7 divided by 5 will be negative 1.40. And then again, the units are newtons over seconds. Now, when we know the slope, so this is how to calculate the slope. The second thing that we will treat here is how to write the equation of the straight line. And in physics, in 99% of the cases, we work with a straight line. Even if it is not a straight line, we try to make it a straight line. So now we will see how can we find the equation of a straight line. To find the equation of a straight line, there are so many ways, and I'm not going into it because it is one unit on Math 10C. However, what we will use on the physics is we will use two forms. We'll use the point slope form to convert it into slope y-intercept form. So when we have a point slope form of the line, what we have is something like this: y minus y of point A is equal to slope x minus x of point A. So if we have a point A, so this is map 1. If we have a point A with coordinates, let's suppose the 2 and 2.3, let's say, and 5.8, which means that this is x and this is y. And we know, or we calculate the slope to be positive 2.4, whatever units is it, then we can write the equation of the line using the point slope form as y minus y of the point, which is 5.8, is equal to slope, so positive 2.4 x which is the variable, minus 2.3, that is the x coordinate of point A. And what do we do on this case is, or usually on physics, that we don't leave it as the point slope form. This is the point slope form of the equation of the line, and it is great, it is fine. But what we do is we convert it into that is known as the slope y-intercept form. And on this case, when we have this form, what we do is we use distribution. So the 2.4, positive 2.4, is multiplying x and is multiplying negative 2.3. So then we'll have y minus 5.8 is equal to positive 2.4x minus 2.4 times 2.3 will be, is it 5 point minus 5.52. And then we, to write it into slope y-intercept form, we will write it into y is equal to mx plus b, where m is the slope and b is the y-intercept. In other words, we will leave the y on its own. We'll leave the y without adding nor subtracting anything. So then what we do is to cancel the negative 5.8, we add 5.8 in both sides. So then y will be equals to positive 2.4x plus 0.28. What this form, this equation of the straight line, which those two, this one and this one here, are representing the same line in a different forms. Okay, you probably have noticed how much we like to talk about the same thing in different forms. Okay, even when we are doing unit analysis, we're doing the same thing. Even when we are talking about the equation of the line, we are talking and expressing it in the different forms. The same line in different forms. This is slope point form, so slope and the point form, the coordinates of the point. And this is the slope and y-intercept. On this form, the number that is multiplied by x, or the horizontal, or the variable that is on the horizontal, is the slope. And the number that is without anything is the y-intercept. Graphically, a line like this will be represented like this is y and here is x, and then we have as a positive 0.28 going like this, and a positive slope that is, in our case, let's say it's 2.428. So this was in terms of writing the equation of the line when we know a point and the slope, either given the slope or we are calculating the slope. So we know how to calculate the slope. We know how to write the equation of the line when we have a point given and a slope either given or calculated. And now what we will see is how can we find a point on the graph when we know, so how can we find the y value of a point when we know the x value of it? So now we'll deal with the third part of the lesson, which is finding the y value knowing the x. And for this, what I will do is I will take a situation which will be very similar to what you will see on the practice. So force in newtons versus time in seconds is something like this. It's starting from 0, 0, and it is going up to positive 24.8 newtons for 7.80 seconds. Well, we don't have to say it here seconds because we have stated the seconds there. So first we'll find the slope and then the equation of this straight line. And then we will find so let's start with finding the slope first. We were expecting that the slope is positive because the line is going up, and then like in every case the slope is delta y over delta x, or delta force change of whatever is on the vertical over the change that is on the horizontal. So the change on the vertical is this one here from 0, 0. It is starting at 0, 0 and is going up to 24.8. So will be final, the force final minus force initial, and time final minus time initial. So positive 24.8 minus 0 over 7.80 minus 0. So the slope will be equals to positive 3.18. Now that we know the slope, we can figure out what is the equation of this line. So the equation of this line using the slope point form will be y minus ya is equal to slope x minus xa. And ya, our point A, is with coordinates 0, 0. Okay, so this will be y minus 0 is equal to positive 3.18 x minus 0. And when we convert this into the slope point y-intercept form, then this will be y is equal to positive 3.18 x. Or since y in our case represent the force and x represent the time, this will be 3.18 times time. Now, if we know, or if we are looking for what is the force at a time that is, let's suppose, 5.18 seconds, then force for time equals 5.18 will be positive 3.18 times 5.18, that is the time, because this is what we will substitute it with. So 3.18 times 5.18, we will have a force that is with a value of 16.5 newtons. So this will be positive 16.5 newtons. Now, if we are asking, or we are asked to figure out what is the impulse up from 0 to 5.80 seconds, this is the area under the graph. So when we are calculating the impulse from time equals 0 to time equals 5.18 seconds, then is the same as saying is the area under the graph. Which means that since we are dealing with a triangle, the area under the graph will be 1/2 base times height. And base is 5.18 seconds times height is positive 16.5 newtons. And then 16.5 times 5.18 divided by 2 will be positive 42.7 newtons times seconds.